Hey guys, welcome to your Chapter 8, Lesson 5 notes on factoring trinomials. X squared plus bx plus c. Remember, trinomial is a polynomial with three numbers, with three terms. You've got your x squared, you've got your bx, you got your c. So we're going to look at the pattern that forms from trying to find those factors. Now, a factor is what you get when you multiply or when you unmultiply. So here we've got a product, and the two factors are x plus 5 and x plus 2, right? So that's what a factor is. Each of these is a factor. So x plus 5 times x plus 2 means they're factors, and then the product is going to be their answer. And there are several ways to do this. You guys like to distribute, you guys like to FOIL, you guys like to draw the rectangle. You can do whatever. I'm going to show you with the rectangle way. Okay? So it's like we have a rectangle, and if we want to find the area inside, the amount of space inside is going to be the length times the width. So I can split this length into, okay, well, this much is x and this much is 5. Sure, why not? And then this much is x and this much is 2. So got x plus 5 there, x plus 2 there, great. To find the area inside, I can say, okay, well then this area is just x times x, and x times x is x squared. You know, this is only a diagram because obviously this is not a square, this is very rectangular, but that's okay. To find the dimensions of this rectangle, we would do 5 times x, which gives us 5x. And to find the dimensions of this rectangle, we would do x times 2, which is 2x. And then to find the dimensions of this rectangle, we would do 5 times 2. I said x times 2. Yeah, and then this one is 5 times 2. 5 times 2 is 10. Now, that means the area inside this rectangle is x squared plus 5x plus 2x plus 10. But we've got some like terms here. 5x plus 2x is 7x. So this is actually equal to x squared plus 7x, plus 10. And that would be our product. Now, that's what we've been doing. What we're going to do today is we are going to undo that. We're going to start with a trinomial. We're going to figure out how do we break it up. So I'm going to do one, and then I'll show you what the key idea is. Okay? So here we have x squared plus 11x plus 24. So basically we want to figure out, okay, if we've got x squared plus 11x plus 24, we need this space to be equal to that. So we're going to make an x squared square. We're going to make a 24 square. So we started by taking our first term and putting him in the top left corner. And then we take our last term and putting him in the bottom right corner. And now all that's left is 11x. And we need this 11x total space here. But we don't know exactly what each part is going to be, but they have to add up to 11x. And now we need to figure out what's the dimensions of this rectangle to make this true. Just like back here. In order to get a 10, we have 2 times 5, or 2 times 5. In order to get x squared, we have x times x. And look, 5x plus 2x, you add those up, and that went to our middle term. Yay! So the question here is, what would make this x squared? Well, there's only one answer there, and that's x times x. It has to be x times x equals x squared, in fact. X times x. Now, what multiplies to get 24? We could do 1 and 24, but that would give us in this box an x and then a 24x. And that doesn't add up to 11x. That adds up to 25x, so that's wrong. Instead, the option that we would want is we want to end up going with 3 and 8. Because that means in our tall green box, we would get a 3x, and in our wide green box, we'd get an 8x. And 3x plus 8x is 11x. So that works. So did it add up to get 11x? It did. Did it multiply to get 24? It did. And that's going to be our key idea right here. So our factors end up being, I need a new color on here. There we go. So our factors end up being the length of our rectangle. So that's going to be x plus 3 times x plus 8. And that is our final answer. We broke it up into factors. You can check your work by saying, okay, well, does this actually multiply? You're like, yes, it does. Because if we FOIL it out, we would get x squared plus 8x plus 3x plus 24. Oh, and lo and behold, 8x plus 3x is 11x. And that's the trinomial we started with. That equals our answer, our question, our problem. Yay, okay? So that works. Now notice that our x squared here matches this x squared here. This 8x matches this 8x. This 3x matches this 3x. This 24 matches this 24. That is no accident. Cool? Cool. So what did we try to find? How do we know this was correct? Well, in looking for x squared plus bx plus c, we needed to find two numbers whose sum is b. That is, they add up to b. I don't like that overlap. They add up to b. And then we needed to find two other numbers whose product is c. That is, they multiplied to get c. That's our key idea. We're going to move this down here. Okay, cool. I like to draw this table rectangle thing, but you don't have to draw it every time. Instead, all you need to know is, okay, well, what adds to b and multiplies to c? And just to add to our little arsenal here, we've got, oh, there's no a, x squared plus bx plus c. Okay, what adds to b multiplies to c. So if you just want to ask yourself, hey, self, what two numbers add to -6 and multiply to 8? I mean, if you can look at it and figure it out, that's fine. All the power to you. So I like to start with things that multiply to 8. So I know there's 1 and 8, 2 and 4, 4 and 2, 8 and 1. Okay, cool. But, you know, 2 and 4 and 4 and 2, that's like the same thing. So we really only need these first two. And now we need to figure out, do they add to -6? Well, 1 plus 8 is 9, and 2 plus 4 is 6. Oh, 6, that's nice. But it's a positive 6. It's not a -6. So now we need to think outside the box just a little bit. Yes, 2 times 4 is 8. But you know what else is 8? -2 times a -4 gives us a positive 8. And -2 minus 4 is a -6. So we just had to think of negatives here. Okay, cool. We've got our numbers now. Those aren't our numbers. These are our numbers. What do we do with them? Well, we take our other guy has to be x. So our answer is going to be in the form of factors. That's two expressions multiplied times each other. We know one of our numbers is going to go here, the other one goes there. It doesn't matter which one goes where. I like to go from smallest to biggest. I guess who's have smaller absolute value, whatever. And then we didn't include our x's. So we need to have x minus 2 times x minus 4. So if you can just look at the numbers and figure them out, that's fine. Make sure you're at least writing, hey, I know they need to add to -6 and they need to multiply to 8. So write down that much work. It's also a good idea to write out your factor pairs. So we wrote out factors of 8, like 1 and 8, but that didn't work out. So we can cross it out. And then 2 and 4. Hey, that was the one that worked. Yay, amazing. that was great. Okay, so those are your strategies. There's also like an undistributing strategy that you can do as well. So here, let's see. I don't know that strategy very well, so I don't like to use it. Yeah, because at its core, okay, so what are we trying to find? Okay. So at its core, we're trying to find ways to add up to 9 and to multiply to 36. So I can rewrite my 9x as a combination of two terms. I can say 9x, you mean 12x minus 3x. Ha! Okay, and unless you know where you're going with it, it's hard to figure out what those two should have been. Why did I pick 12 and 3? Why didn't I pick 11 and 2? Or 4 plus 5x? You know, right? But I'm going to show you this method just in case you want to use it. So we have x squared plus 9x, which is really 12x minus 3x, minus 36. And now we can undistribute something. What do these two have in common? Well, these two terms have an x in common, so I can undistribute out that x. I would get x times x plus 12. Cool. Well, then let's look at these other two terms. What do these other terms have in common? Well, they're both divisible by 3. In fact, they're both divisible by negative 3. See how they're both negative 3? Cool. So I can pull a negative 3 out of there to give me an x plus 12. Oh, hey, that's funny. What a strange coincidence. That's not a coincidence at all, but these match. So I can undistribute yet again, pulling out an x plus 12 from both of these guys. And what am I left with? Well, I'm left with an x, and I'm left with a negative 3. So those are my factors. My factors are x minus 3 times x plus 12. And now we can check that we did it right by multiplying it out. So we would get x squared plus 12x minus 3x minus 36, which is an x squared plus 9x minus 36. Oh, check it out. That's what we started with. Cool. But how did I know? Excuse me. How did I know how to split up my 9x into 12x and 3x? Why didn't I split it up into 5x plus 4x, for example? That's because I saw it coming and I did this problem already a different way, so I knew what the answer needed to be. Ha! But if I had split this up this way, we would have gotten two different answers. If I had pulled an x out of here, I would have gotten x plus 5. And if I would have pulled a 4 out of here, I would have gotten x plus 9. And those wouldn't match. So I needed to get blue factors. I needed to get blue guys that matched. So if this way is confusing for you and you don't want to do it, that's fine, because guess what? The box still works. So you can still try to figure out that way. Or the adding to b multiplies to c still works. So here our c was negative 36. If you wanted to figure out, okay, well, what multiplies to 36? 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, and then you keep going. 9 and 4, 12 and 3, 8 and, okay, right? But now you just need to figure out, when we add them together, how can we get 9? But shoot, it's negative 36. So one of these needs to be negative. There we go. And then you see this actually adds up to 9, so that's the one we want. So I ended up going through this whole process in my head before splitting it up and undistributing. And that's how I knew how to split up my 9x. So there you go. Okay, we've got one more. Well, what happens when we have two variables? It's not just numbers anymore. We need to split up these variables. Well, that's okay. I'm going to use the box method to show you why it works, but you can use really any method you want. Okay, so here we know that our first corner needs to add up to our first term, or rather multiply to our first term. And our last corner needs to, our opposite corner needs to add up to our last term, negative 55y. Cool. So you can already tell, all right, this has to be x times x. And this has to be something y times something y. Oh, shoot. This should have been a y squared. Yikes. Guys, make sure that's negative 55y squared. My bad. Or else it wouldn't work. Ah. Yay. Okay, anyway. So it has to have y times y to get that y squared. And now the question is, well, what multiplies to negative 55 and adds to 6? So let's keep trying. What's nice about 55 is there's not a lot of pairs that multiply to 55. You've got 1 and 55, 5 and 11. Okay. But they need to multiply to negative 55. Oops. So that means one of them has to be negative. And when I'm dealing with negative numbers, I like to write the whole list out, because there's a difference between negative 5 times 11 and negative 11 times 5 when you're getting to adding them up. Okay, now let's add them up. Negative 1 plus 55 is 54. Negative 5 plus 11 is 6. Oh, yep, that's it. End of story. It adds to 6, and that's what we needed, so we're going to stop. Cool. You may have noticed I've been doing kind of trial and error. Does this one work? Nope. Okay. Does this one work? Yep. Okay, I'm done. And that's fine. Trial and error with the factors is totally fine. We did that up here too. Does this add to 9? Nope. Does this add to 9? Nope. Does this add to 9? Yes. Done. Got it. Okay, so that means we need to have a negative 5y times 11y. Now let's go into our chart and see, does it really add up? So you've got negative 5y times x is negative 5xy. And then going into this guy, we've got an x times 11y gives us 11 times x times y. Now do these green areas, do they add up to a 6xy? They did, that's how we picked them. So you know we did it right. Sweet. Remember our factors, our final answer, our solution is the side lengths of our diagram. So it gives us x minus 5y as one factor times x plus 11y. Now how do we know if our correct solution is in fact correct? Well, multiply it out, see what you get, and I will let you do that on your own. I will also let you have a fantastic time on your homework, remembering that this is what we need. You need to find two numbers that add to b and multiply to c. Know it, love it, have a great time on your homework.